Hey guys, Cool here. Going to do a video. Hey, I got kind of changed up my whole video here today. Yeah, I come across some stuff as I was actually making my other video, and I want to, show that a little bit better and more. But anyway, before we jump into that, obviously the transit of Mercury happened today. Scott did a video on this. I would suggest everybody go over and check that out. I'm going to show you a little piece of it just so you guys can get an idea of what's going on. But it is the transit of Mercury between us and the sun. And we're not going to be able to see this again until 2032. So this is why this is kind of a big deal. It doesn't happen very often. And again, that should tell you it ain't going to happen again for another 13 years, I think. Is that what that computes to? Yeah, 13 years. So as we're looking at this, I just want to show it to you real quick, but I'm going to show you a little bit. This is the 211 angstrom on the SDO. I think Scott updated this or upgraded it to 4K, which is software, but check this out. It's pretty cool. So yeah, go over and check that out, guys. He did a good job on that. But yeah, so we're going to talk about something else here real quick. So yeah, I went to my window today and I looked out the window and there's this white stuff falling from the sky and sticking to the ground. Really cold stuff. If anybody knows what this is, let me know. Just kidding. Anyway, it's snow, obviously. Just having a little fun. But yeah, so why am I talking about this? Well, it's kind of early in the season for where I'm at to get snow. We're also getting a huge cold blast. All right, we're talking like January weather in November. This isn't unheard of, but it's most definitely not normal. What I will say to this is, this conversation is very polarized. No pun intended. What I mean by that is you either think the planet is going into an ice age or we're having some sort of massive global warming. There is no in between. Most people don't have a gray area there. And, in my opinion, that's kind of unfortunate, but it is what it is. I'm not sure even where I stand when it comes to that. I think there's evidence for both, to be honest with you. But I can say this, that I think we can all agree that our climate's changing globally for whatever reason. Okay? Something's changing. We don't get spring and fall anymore. We get like 1 or 2 weeks of each. It's either, again, it's very polarized. Either summer or winter. So I wanted to bring that up. Yeah, and we do report on this from time to time. We don't typically report on the cold as much. Scott's done a lot of videos on the polar jet stream, and others have also. Okay, how it's been splitting into threes sometimes and dipping down further than it ever has. And it happens in the southern hemisphere also. So we do talk about it, but we don't. And the reason why is because hot weather makes us very uncomfortable. Okay. And there's not much we can do about that. Cold weather makes us real uncomfortable too, but we can at least put on more clothes. So we can't really run around the streets naked, right? Unless we wanted to go to jail or traumatize each other, especially if you've seen me. But anyway, just kidding. But yeah, so I wanted to touch on that for a minute, just to bring that up. All right, guys. We've been talking about this solar wind stream that's supposed to be getting to us. It got here, okay? We've been seeing some hits on our magnetosphere. The geomagnetic storm level kind of raised a little bit, still kind of hanging out there. It didn't get into storm level range, but it did pick up from what it was. It was on the bottom. It was basement out, right, guys? It was like way down low. And when that happens, we are more concerned with cosmic rays. That does allow more things to come in when that's going on, but right now, we're raised up to like a level 3, I think, or a number 3, I should say. Not really a level. It's like a KP of 3. We're not in any kind of even little minor storm level at all. But I'm going to show you this, okay, because I come across something kind of interesting. This is the solar wind map, okay, the model I show you guys quite often. Okay, and obviously you see it, okay. And again, the wind speed's up here. Okay, so wind speed picks up, right? I mean, this is pretty typical of what we would see during a wind coming from the sun. I guess I should say charged particles, because it's not really wind as we think of typically here on the planet. Now, I was doing this, and I just kept going, right? And I was doing this, right. Okay. And something caught my eye. I don't know why I seen this. I really don't. But it did. It caught my eye. So what am I talking about? Well, I'm going to toggle this one frame at a time. And this gives us a capture every 4 minutes. That's important for what I'm about ready to say. Okay, so that's 2122. The wind speed's at 365 up there, right? Up here. Okay. Now you can see how the intensity is picking up right there via the orange color out in front. Correct? So watch what happens. That's 2126. 2130. Wind speed's picking up just a touch, 425. 381 kind of drops back down at 2134. Look at that. That's it. 21, 23 kilometers per second. That is extreme. We don't hardly ever see it get higher than that, ever, even during a big solar storm. Okay? That's a high number, guys. I mean, wow. And it was only there for one frame. Now let me show you what's going on here. Okay, so this is the one before. Okay, and then 4 minutes later, it gives us 2138. It's seen that. Now watch this. See the time frame? The timestamp? 2138. 2138, 26 seconds. 2138, 18 seconds. It gave us another capture 8 seconds later. Why? Okay, I've seen this thing do weird stuff before, but this is nuts. Okay, whether it has some sort of whatever going on with the program, like if it sees a very high one, maybe it kicks in and wants to see the next number. I don't know. Or did they try to wipe this off so we couldn't see it and they messed up? I don't know where I stand with that yet. Okay? Okay, because it goes right back down to 379. That was just like a quick burst. 381 to 2123 to 379. All in a matter of 2-3 minutes. Okay? And this thing gives, like I just showed you guys, it gives us a capture every 4 minutes. Why did it decide to give us a capture in 16 seconds? Right after we seen that high wind. Okay? I don't know why. I can't give you a reason. All I can tell you is that's very intense. And it does relate straight to the earthquake conversation. And I'm going to show you that here in just a second. But that is extreme. Now, what does that compute to? I'll show you. That computes to 4.78 million miles per hour. Close to 5 million miles per hour, guys. That's extremely fast. Okay? Now, I've been trying to think about what could cause something like that, just to spike like that for 2 seconds and then go right back down to 300. Okay? So, just to give you an idea, that's 4,782,000 miles per hour. I will enter in 350 right here, which is what it basically went right back down to. How fast is that? 782,000 miles an hour. So it changed 4 million miles per hour in 16 seconds. That's crazy. Okay? I don't know what's going on here. I really don't. All I can say is that was a hit, and we took it hard. You know, I'm pretty sure we handled it well, but I do think this comes into the earthquake conversation we're getting ready to have. All right, guys. This is USGS, and yes, we know that they drop numbers. Okay? They do. So what we're going to talk about, this is the earthquake that happened in France, guys. Okay? The biggest one that hit them in over 15 years. Okay, there's lots of videos showing the actual shaking. I'm not going to show you any of those. Just Google it. They're all there. There's tons of them. It only lasted for like 10, 15 seconds. Okay. But it did happen. All right. Now, I'm not sure if that's the actual first one. Let's see if it may have happened a little bit before then. But yeah, this one here says 4.8. It was like a 5 something. So it was over a 5. So just keep that in mind. That happened today while we're in the midst of this solar storm. And, like I said before, we were talking about this in my last video that, when we get these solar storms or solar wind increases, whatever you want to call them, from coronal holes, we have to add that into our earthquake equation. Okay? Now, this isn't what causes earthquakes to happen. Okay? It's just part of what causes them to happen. Can we get earthquakes outside of increased solar wind? Yes, we can. Okay? It's just we have to be on more of a lookout when we're getting strong solar winds. And, more and more mainstream are starting to come into that way of thinking, but it's not across the board yet. They need to figure this into the equation. And that's why we, especially here, and Scott talks about it, and other people that do our research, we speak on the earthquake thing because of this. All right, because it always coincides. Almost every time when we get solar wind increases, we see upticks in earthquakes, intensities, and everything else. So that timestamp that I showed you guys earlier was at 21:38 or something like that. Okay. Well, this happened before also. This was in Hawaii today. Okay. That was actually over a 5. I think it was like a 5.2. Okay. Can you guys see what we're talking about here? This uptick that's going around this when the solar storm started. Okay. So anyway, and again, so then we go up here. These bigger ones happened within 1 hour of that big blast I just showed you guys. So it's hard for me to not to be like, man, that really contributed to what we see here. Okay? This was within 1 hour, about an hour and a half of when that big blast of solar wind we got. That was almost 5 million miles per hour. So I just wanted to show that to you guys to kind of make people understand that this is one of the reasons why we issue these earthquake watches. Again, I'm not the best person to go to for earthquakes. Obviously, Dutch Sense would be the first one I go to. And then Scott, and then others out there also. BP Earthwatch talks about it, and other channels do too. And they take in consideration solar weather. So, and they're very good at what they do. Now, I'm not sure if Dutch Sense does. He has his way of doing things, but he seems to be right on it almost every time, which would tell you that earthquakes happen outside of solar wind too. I just think that when we get these higher winds, it does contribute and sometimes makes things happen. So, but yeah, guys, I wanted to bring that to you because, man, that was fast. And I was making a video, guys, and I stopped and just redid my whole video because I wanted to do a little research on that before I posted. So, but anyway, guys, I am going to end it here. Go over and check out Scott's video on the Mercury Transit, and stay alert to the earthquake stuff. This solar wind stream is not over yet. Okay, watch my model update after this. I put some I don't know, I think there was some, can't remember what music I put in there. I think it was some Def Leppard, some Phil Collins, and I think Van Halen, I'm pretty sure. I can't remember which ones I picked today, but again, anyway, guys, go check that out. This is what's going on right now, and God bless. Shiva saves, and you can drink this Kool-Aid.